Welcome back to our LeetCode contest series, and I got late in uploading this last question of our weekly contest 388, but we'll see it now. So you're given a zero indexed array nums and an integer k, and which is going to be odd. Okay, now there is some formula they've given how to calculate the strength of the array or the subarray. Okay, we'll see it by example. So the main question is we need to select k distinct subarrays. Okay, and strength should be max. Okay, okay, and we need not cover whole array, so we can skip a few elements from the array as well. Okay, so we'll see this example and boom, and k is 3. Okay, so now what they've done is they've created a three subarrays from it. Subarray 1 is 1, 2, 3. Now subarray 2 is just -1 and subarray 3 is just 2. Okay, so now the strength is, if you see, the strength is for what we'll do is sum of S1 into Rk, then sum of S2 into Rk minus 1, then sum of S3 into K minus 2, which will give me, which will be 1 plus 2 plus 3, 6 into 3 plus -1 into, okay, there's one more thing to it. Actually, this plus and minus are going to be alternative. They've given in this also minus, then plus, and then again minus. So we'll take it as minus and we'll take it as plus. Okay, so here it will be minus and then -1 into our k minus 1, that is 2, then plus this is going to be 2 into 1, which is going to be our 18 plus 2 plus 2, which is 22. Yeah. So this is the formula of strength. So the number of subarrays that we need to create will be k, and the sum and the strength would be sum of the first subarray into k, then minus sum of second subarray into k minus 1, then plus sum of third subarray into k minus 2, and then again minus plus for every subarray, and k goes on decreasing. So this question seems to be very odd and seems to be very tough at the beginning, but when we think of recursion, then it seems to be a bit nicer. But in recursion also there is one point that hits, and that was the main point that I was also missing, but then I got to know. Yeah, so we'll see how we can get through this question via recursion. So see, we need to this questions how I came about that we can go through recursion is, the idea is that we need to select k distinct subarrays. Now I've got so many choices. uh, Whenever I've got choices, then recursion is the best idea, and here the choice lies in whether or not I should take an element in one of the subarrays or not, right? So I'll create few cases. Suppose I am on some element, right? Element choices, and what choices do I have? One is I can skip that element, right? The next one is I can take this element in my subarray, right? And the third one is take this element in my subarray and end it here and end the subarray. So see, we've got these three choices. When I'm on some element in the array, I've got these three choices. One is I can skip that element. Okay, I'll not take this element and I'll move on. The next one is I can take this element in my subarray and I can move on. Take this array in my take this element in my subarray and move on to add more elements, right? And the next one is I can take this element in my subarray and end that subarray so that we can start a new subarray later on. Now this might seem like, suppose I've got some recursive function, suppose recur, and which will take my nums, and suppose index, And that's it for now. Suppose I've got this, right? So what choices do I have is, if you see closely observe, is first one, what I can do is I can skip that element. So I can directly go to my, and also I'll take k, right? So what I can do is I can directly skip it and I can do nums idx plus k, you go to this next element, right? I went to next element, skipped it, right? Now what else I can do is I can do recur and I can take this array nums, and I can just, when I'm returning, I can just take this nums idx plus, because I've taken this array, and I can just send it to next array, next element, and I have not uh, ended this subarray. I've not ended this subarray. So what? So I still have k, right? Because I'll add more elements. Now the next one what it can be, I'll take this element and I'll do nums idx plus 1 and k minus 1. Now why k minus 1? Because add and end the subarray. And this is add and add more elements to the same subarray. Now, in this case, k minus 1, because I'm ending this subarray right here, right? And we can have some base conditions like if my k becomes 0, then I can return 0. If my k is 0, just return 0. If my n is 0, then return some big value or small value, return small value, because these conditions we do not want. This condition is, this is our base condition, which is wanted, that our k becomes 0, and this condition we do not want, because in this condition k is not 0, and if k is not 0, that means we haven't got those many of our distinct subarrays. So this is unwanted condition, right? So we'll return some small value, right? So now this part, and later on what we can do is just to, because this question, as you can see, the constraints are very high. So this won't be solved by the simple recursion. We'll need to apply memoization. That I'll show how we can add. That won't take much time. That would be easy. But see, these conditions, if you see closely observe, this seems to be right, right? But there is one catch to it. The main catch is if I skip it, okay, this will work fine. Now suppose I'm on my index 0. I'll take this condition. I'm on my index 0. Okay, and I'll add it num 0, and I'll move to next, that is nums 2, and k is intact, that is 3. Okay, I'll move to 1, right? So now this says that I'll add this element and I'll add more elements to the same subarray, right? Now if I'll add the elements to the same subarray, so when I'll run this recur for nums and index 1, it should not go to this point or to this call. Why? Because I've already instructed it that when it's coming from this, from here, we should not skip the next element, because the next element should also be added to the same subarray. If we are skipping, that means we need to previously end the subarray. Like here, if I'm running this one, I've taken this array and I'm ending it. In that case, I can run it because I've already ended my subarray, and I can skip the next element and I can form the subarray some later on index. But in this case, this is the crucial part. I need to take care to not skip. So this is the main part. In the next recur call, do not skip the next element. Yeah, so this was the main part. If I continue to add elements to the same subarray, condition 2, then do not skip, right? So what we need to do is we can take one more variable here, suppose a boolean or an integer, and skip, which is going to be initially as true, right? So what I can do is I'll just check it here. If I'm able to skip, if skip, then only I can be able to skip, right? and in this case I can send true because next element also I can skip, and in this case also I can skip the next element, true. But in my this case I should not be able to skip because I have to add the next element as it is part of the same subarray. So this was the main what we can say, the main hurdle, or the skipping part was the main hurdle of it, which was making this question so tough. So we'll see and we'll walk through the code and we'll see how this is working. Okay, so what we did, DP I'll show at the end how we have made the DP. So I'll skip it for now. Okay, we just returned one and index. This is the index, this is K, and this is our skip. Okay, so we'll directly come to this. Okay, I'll just, yeah. So private long fun, this is our index, nums, K, skip. So skip, what I've done is, uh, skip is either 1 or 0. For 1 it is true, and for 0 it is you can't skip. Okay, so now if K is 0, this is our base condition, return 0. We are happy about it, right? Where I'm just taking out the length, and if length becomes n becomes equal to our length, that means we have finished our array. This condition means reached end of array without having k subarrays, because k is not equal to 0. So I'll return this. Now for long, I'll return this 10 raised to the power, I guess it is 15. This is an ideal case. Do not return long dot min value. If you'll return long dot min value, here we are also doing some addition operations, and this would even exceed long. So do not do this. We can just put in 10 raised power 15. Okay. DP I'll skip for now. Okay. So I've taken the result as 10 raised to power minus to the power 15 in negative. And now sign. Yeah, there's one more thing we forgot, that is sign. This plus minus is going to depend on our k. You see, first time it is plus, right? Second time it is minus, then next time it is plus. So what we can do is, in k we are given that k is always odd in our question. K is odd, yeah, it is given. So k is odd. So if k is odd, then we can find out whether this time we have to do plus or minus. So k is odd. So suppose our k is 3. So in case of 3, first time k is 3, so we have to do plus. Now next time k is 2, now we have to do minus. Now next time k is 1, we have to do plus. You see, k is 3, we are multiplying by 3 here, so it is plus. We are doing by k minus 1, so it is minus here. So in this case, the only condition is we need to check k mod 2 not equal to 0. So if k is odd, then we need to do plus. Simple. So it is 1, otherwise minus 1. Now we are taking out temp. Now temp is, okay, suppose here what we are doing is we are doing sum of s1 into k. Now sum of s1 is, I'll take this one, into k. Now sum of 1 comma 2 comma 3 into k, that is 3. So what we can do is 1 plus 2 plus 3 into 3, or we can also do is 1 into 3 plus 2 into 3 plus 3 into 3. That's what we are doing here. Individual element I'm multiplying by k, and sign. Sign has to be there, right? So if skip is equal to 1, I'll skip this element. I'll directly move on to, I'll find out the max, and I'll skip this element plus 1. K is same, and we can skip again. Now if I'll continue the same subarray and add more elements, so what I'll do is mat.max, and I'll add this element plus next element I'll move on to, and k is same, and we can't skip next time. Do not skip. So skip is equal to 0 or false. Now next time I'll end the subarray here. So k minus 1, and I've taken the sum of it, and skip, we can skip, right? So now we'll move to our DP part. So when we are defining our DP, what we need to take care of it is what fields are changing every time. So if you closely observe, our index IDX is changing, okay, and our K is changing, and our skip is changing. So there are three elements that are changing with for us. So we have to take 3D array. So I've taken a 3D array of long, and now first is the IDX. For IDX, it can go up to num start length. And k can go from 1 to k. Now 1 to k, that means k can be from 1, 2 and 3. So if I'll put just k, then it will give me k3 would give me just 0, 1 and 2. So I need to take k4 so that it can give me 0, 1, 2 and 3, right? So k plus 1 and 2 because I just want 0 and 1 for skip. Now I'll just initialize it with minus 1l, right? This function is for arrays.fill. It will fill it, or what I can do is I can directly do it like that for int k equal to 0, k is like then dpij dot length like that. That won't cause any issue, right? So now what I'll do is I'll pass in dp every time, and what the main thing is I need to check if this value dp idx k and skip is not equal to -1, then directly return it. And at the end when I'm returning the result, that time also set that value. So that's it. I hope I have made this question clear, and I've told you how you should approach a recursive question, how you can go to the recursion approach, and how you can make any question for the DP, right? So I hope this is really clear, and this is submitted also, works fine. Thanks a lot.